Hi, I'm Etta Spencer, and we have to go to the Arctic today. It's not my favorite place this kind of year, but at any rate, it's very important. So, we're going to talk to two guys who know a thing or two about climate and who are going to brief me and probably you on what they encountered in the Glasgow meetings of COP very recently, about a month ago. So, in Milan, or no, not in Milan, in Turin. Is that where you are, Peter? You're in Turin?
Yes, sure.
Turin is Peter Wadhams, who's the leading world expert on sea ice, and he's going to take us north today. And in Ottawa is Paul Beckwith. But
Great.
let's get right down to talking about what's happening in terms of climate change, what you have learned in the meetings in Glasgow. And I think, Peter, you've been off in Greenland recently, looking at ice and stuff. So I don't know who wants to get started, but let's say, Paul, give us a short introduction to what you've been through the last month or so.
The Arctic is warming so fast. And for years I've been saying 4 to 5 times faster than the rest of the planet, whereas, in any media article, it would say twice as fast. And now the media articles at least are saying 3 times as fast. And the recent paper from the American Geophysical Union shows a plot where comparing the Arctic warming to the overall warming, and it's more like about 4.5 times faster. Of course, that warming in the Arctic is doing a number of things. The primary thing is it's causing extreme weather events around the planet because the jet stream has slowed down and become wavier and gotten stuck in place. So we're getting all of these extreme weather events occurring. An increase of frequency, severity, and duration. Just a couple quick examples could be the massive atmospheric rivers that have gone into BC and destroyed huge numbers of roads and infrastructure and caused massive flooding. The clash of warm and cold air over the U.S., which led to a massive tornado swarm in December, which caused huge damage. I mean, it's like a war zone. This mile plus wide swath, 250 miles long. And there were multiple tornadoes. That was just one tornado, causing tremendous damage, F4, F5 type winds, which, basically, leveled any structure in the path, basically anything there. And sent 2x4s sticking into truck tires and toward bark off trees, and just this huge devastation. Massive superstorms, like the one that just hit the Philippines, causing massive destruction and flooding. So the weather, I call it weather weirding, weather wilding, and weather whiplashing in the climate casino. These things are happening because of the changes in the Arctic. We're getting more and more heat waves up in the Arctic. And that's, of course, melting thawing out the permafrost, both on land, and the warm ocean temperatures are thawing out the permafrost on the seafloor. So we're getting more and more methane coming up in the Arctic. So the methane rise in the Arctic this year, even this winter, is extremely alarming. Larger and larger quantities of methane coming up. But it's not just methane, it's CO2 and also nitrous oxide. And the global warming potential of nitrous oxide that's coming up is about 300 to 1 compared to CO2. And for methane, on a short time scale, it's about 150 to 200 times the warming potential of CO2 is for the methane. People average it on a 20-year time scale, it's still 86 times worse. And on a 100-year time scale, which makes no sense really to do, but they do it, and it's 34 times worse because the methane lifetime is only about a decade or so. So, and I fully expect it to take out enough of the global food supply within 5 to 10 years that we get a global famine. So this is what's happening on our planet right now.
Okay, that's a very cheery beginning. Merry Christmas. Woo. All right, Peter. Do you have any quarrel whatever with what we've just heard?
No, I agree completely, and I can add one or two things related to personal experiences. First one is that the extreme weather events that Paul has talked about affect, of course, everybody in the world, but they've been affecting scientists who are studying climate change as well. And one of the best known people who suffered from the typhoon in the Philippines is Brian von Hertzen, who from Harvard, who is working on a very important field, which is how do you get rid of carbon dioxide from the atmosphere. And one of the ways that more and more people are trying to develop is getting rid of carbon dioxide from the oceans, and then the carbon dioxide will reorganize itself so that some comes out of the atmosphere to compensate. So he had an operation growing kelp in submerged mats, and the kelp then is pumped away or taken away, and it gets rid of carbon dioxide. So it's a carbon dioxide removal operation. But his entire operation was destroyed by this recent typhoon, and in fact he lost one of his employees as well. It's so it's quite dangerous even to try to study climate change, let alone be at the receiving end. And the other thing that you mentioned, the Greenland, is really a case study of accelerated warming happening in the Arctic, because this multiplying factor, which Paul mentioned, which has mysteriously gone up. In fact, I don't think it has gone up, but people are just aware now of what that ratio is. I remember that when I was first doing writing on climate change, I would the editor of one of the books that I wrote said, "Oh well, this we can't have this amount of warming that you talked about here. We'll put a lower figure down." So I think an insult to science is they wanted to use a lower figure because it wouldn't be so frightening as the figure which is actually based.
God. That's that kind of mentality is just our worst enemy, isn't it? Yeah.
Well, yes. So this multiplier of Arctic warming, which is, as Paul said, that in around about 4 now, was always taken to be 2 because it's less frightening. But once you accept that it's 4, then you're looking at very, very large warmings, given that the standard rate of warming is high anyway, and you multiply everything by 4, you get very, very large warming in the Arctic. And we're seeing that, of course, from the way that we're now getting brush fires in Siberia, which had never been known before.
But is the Antarctic affected in the same way? I don't understand the mechanism or the explanation for why the Arctic is warming faster than anything. I don't understand it. But would it equally apply in the Antarctic?
Well, it's a slightly different mechanism in the Antarctic. What seems to happen is that because the Antarctic is more isolated, it's the ocean system, and the island is isolated from the rest of the world, and there's a very, very strong westerly wind system that blows around the Antarctic, and this has been increasing in strength in the last few years, and the westerly winds, of course, move the sea ice eastwards, but at the same time, they give it a northward component of its motion due to the Coriolis force. It's the force that turns things from their intended direction. And that increased Coriolis force is driving the sea ice northwards, and is giving you actually increased sea ice area up to a point that you're getting the sea ice reaching more northerly latitudes, and it gives the feeling or the impression that you're actually getting an increase in sea ice area in the Antarctic. In fact, you're not, because although it's moving the sea ice further north, it's leaving a big holes behind it. So the actual area of sea ice in the Antarctic is not going up; it's going down. But the extent is still going up. So it gives you the feeling that all is well. Of course, it's not, because we're seeing now a whole new range of nasty things happening in the Antarctic, with glaciers, ice shelves breaking up, and that is going to be causing quite rapid rises in global sea level.
Now, you've been to Greenland, and I think I haven't talked to you at length since then. What was the purpose of that expedition, and did you find out anything surprising there?
Well, yes. Well, you haven't talked to me since I was in Greenland, mainly because I had an accident, not in Greenland, weirdly enough. It was coming back from Greenland. I fell over getting out of the bath. Very, very embarrassing thing to happen to somebody who was clambering around glaciers without any problems. But the Greenland ice sheet is melting very, very fast, and we can see huge amounts of melt in the summer from the you're getting waterfalls, you're getting big runoffs, you're getting the meltwater actually sinking down through into the glacier and down to the bottom, where it lubricates the glacier flow, so that you're getting more rapid.
There are holes or something that goes down, right?
Yes,
the ice? Why, I don't understand that. What makes these holes?
Well, they're called moulin, and it's really just melt, and that the melt gives you large volumes of water, which warms up in solar radiation and melts down faster, and you end up with something which is like an interior waterfall, which is quite dangerous, and in fact a very great glaciologist, Connie Stephan, was killed when he fell into one of these features. The moulins lubricate the glacier bed and make it flow faster, and that increases the rate of production of icebergs. It increases the rate of loss of ice from the ice sheet. And so there's many mechanisms, all of which are causing ice to be lost rapidly. And that is something I found this year as opposed to the previous year. There was the ice was dirtier for a start. Already there were problems with the fact that the glacier ice in Greenland is getting darker. This is dust. People thought was just dust being blown across to Greenland from the Atlantic, and being left behind when the ice melts. You have an increasingly dark layer on the top surface, and that dark layer absorbs more radiation and increases the melt rate. So that has been accelerated even more this year. We took a load of ice and dirt samples, which we're analysing at the moment, and it seems that there's a lot more soot on the surface of the ice, and that's because of all the brush fires that have been happening, especially in the Arctic. It's not dust blowing in from somewhere else in the world. It's soot blowing in from fires, and that's increasing the darkness of the ice. That the ice is blacker than it was last year, and that's increasing the melt rate of the ice and rate of sea level rise. So everything nasty. Just the trouble is, every feedback effect that goes on in the world seems to be positive. That is positive in a bad way, but you don't see any feedback that calms things down. Feedback always seems to make things worse, and one of those is increasing the rate of ice sheet melt.
Mm.
Yeah, these cascading feedbacks, they just build on each other, these accelerating feedbacks. And of course, water weighs about 10% more than ice. So the water on the surface of Greenland is heavier than the ice, and it just works its way down, drills its way down through the ice, reaches the bedrock. And as Peter said, it can lubricate it, which speeds up the rate of movement of the glaciers. But, also just sort of thinking of the big picture here, the Arctic is getting much, much warmer because it's a much darker place. And, a darker place, it's absorbing a lot more of the solar radiation coming in and reflecting much less. So it's causing, tremendous warming. And, that increases the temperature greatly in the Arctic. In fact, we're getting heat waves up in the Arctic. And the jet streams exist because we've got a cold pole, a warm equator. And as the pole gets warmer and warmer, that temperature gradient to the equator gets smaller and smaller. So the jet streams slow down and become much wavier. Now, ice keeps the poles cold because a lot of energy goes into melting ice, right? The latent heat effect. And the problem is when we lose the Arctic sea ice, then the Arctic will notch up in warming. So right now it's 4 to 5 times faster warming than the rest of the planet. But when there's no sea ice left, you can try to estimate what that number would be. I think the Arctic will then notch up warming. So maybe it's 10 times faster warming or more, 10, 20 times faster warming than the rest of the planet. And that will, of course, unleash huge amounts of greenhouse gases from the decomposition of the organic matter that's in the frozen state in the permafrost. And I like this is we're basically, as bad as climate change is right now, and as much as you might hear people saying this is a new normal, these extreme weather events, I would argue that we are just scratching the surface on what we're seeing with extreme events and climate. It's going to get much, much worse, and there's very good science to show why that will happen. And that's part of the thing that people like myself and Peter, and there's not a lot of others, that we look at the entire overall climate system and we're trying to figure out what we're going to see, say in 5 years or 10 years. And scientists, they're going to be like the public, say, oh, we were totally shocked that this happened, we were totally surprised, etc.
It's obvious to me that everybody should say this is the worst emergency facing humankind. We are doomed unless we do something urgently. But I don't know whether you both...
Well, I wouldn't, you used the word doomed. I've never used that word.
Well, okay.
Like we're not. What do you mean doomed?
Because what you're telling me sounds like the outcome of all of this means that there will simply be no habitable place on the planet where if tornadoes and
there will be habitable places. There'll be fewer and fewer of them over time. And then how much time are we talking about? And it's the world is going to be totally changing for sure. A hit to our global food supply and to being able to, produce enough food, there's going to be mass famine. But as you and I and everybody else knows, these things don't hit the earth simultaneously. Like they don't hit different places equally at all. I mean, the world is a very inequitable place, right? There's countries that have a lot more resources than other countries. I mean, how many super typhoons do we need in a place like the Philippines for them not to be able to rebuild anything? And we can talk about countries like that, or we could just talk about the US. Okay, the US is being hammered by climate events, even at a faster rate than most other places on the planet. Vast swaths of the US in the Southwest are getting so hot and so dry that they're already unable to grow the crops that they used to. Water is a huge problem. And of course, when you get the heat waves and the really high temperatures, even, up in Canada, almost, 50 degrees, almost 49.6 degrees Celsius in interior BC in forested regions, and a spark, and the entire forest burns up with the wildfire and taking towns with it. We saw this in Paradise, California, a few years ago. So, you can only feel grief about things for so long, and you go through different phases. And I continue to do my work by sort of just compartmentalizing it. And I'm well past that stage. I'm just of feeling grief for stuff that is going to be no more on our planet. I'm more of this at the stage, and I need to be past that stage in order to, have a rational assessment of the climate system and what is going to happen.
Is that typical of the other climatologists? Peter, do you feel the same way, that it sounds like you're kind of fatalistic? Is that the word for it?
To some extent, fatalist. I'm not as fatalistic as true doom merchants who don't believe we can survive anything. But it is very, very worrying. And there is this special thing about the Arctic, as Paul's been saying. It's since I've been working on the Arctic all my life, I feel somewhat biased about feeling it's the most important part of the world for climate. But it is to some extent true that it is. And in fact, I thought I'd show you the cover of this not nice report, which has just come out, called The State of the Cryosphere 2021, and produced by the International Cryosphere Research Institution.
Were you part of that, or is that a different outfit?
No, it's a different outfit, but the thing I liked about it was that there's a motto on the cover, which I think everybody who's involved in climate research should adopt, which is, we cannot negotiate with the melting point of ice. What they mean is, that when the climate warms, the first thing that's going to happen always is ice will melt, because you heat ice up to 0 degrees and you add heat to it, it melts. So it differs from everything else, vegetation, rock, everything. And so that's why we see these massive changes going on in retreat of glaciers, retreat of sea ice, retreat of snowlands. It's all because it's ice and snow are very, very fragile substances. They turn into water if you just add a bit of heat to them. And that's what's happening. We're adding a lot of heat to areas that have been continually ice covered for the last few tens of thousands of years, and it's going away. So that is the most rapid thing that's going on in the world. Climate is the
okay. So here's a question for you to ponder or think about, Peter. And we haven't discussed this previous, but those atmospheric rivers that BC just got hit with. So these are like fire hoses connecting tropical warm, moist air with carrying huge amounts of water to the land. And they're pouring the water onto the land essentially. And they've been very common in California, like the Pineapple Express, for example, is the best example. It originates sort of near Hawaii and it has that name. But these basically are connections of moisture from lower latitude, warm, humid, moist regions and colder, drier, more northerly regions. So the atmospheric rivers that basically, because the ocean's been warming and the pattern of heat distribution has changed on the planet, we've suddenly had these atmospheric rivers coming farther north into British Columbia in multiple waves, and that rain on hilly terrain caused landslides. Some of it was on regions that had been deforested from wildfires just in the summer, and then it took out roads and bridges and flooded vast regions of BC. And on the other hand, there's been some of these river-like features, atmospheric rivers, feeding warm air from the tropics into the east coast of Canada, Cape Breton, causing torrential rains, washing out roads. So it seems to me that as the oceans continue to warm and as the Arctic continues to warm, I don't see why we won't be in a world where atmospheric rivers go right into the Arctic. And so my question is, if we have some atmospheric rivers going into the Arctic and crossing Greenland, dumping torrential rains over Greenland, then in my thoughts, if this happens repeatedly, that could take out the ice on Greenland in a matter of decades, as opposed to centuries, which is the time frame that the glaciologists, talk to Jason Boxes, and people studying Greenland ice say, oh, it's going to be there for hundreds of years. But with the atmospheric river phenomena going right up into the Arctic, I think that would be a notching up of the climate system, and all the climate scientists will say, oh, we never thought this would ever happen. And, when it happens, and it will basically end the cold and ice in the Arctic.
That is possible. Certainly views are changing about how fast the ice in Greenland is going. And it's the Greenland ice which is, at the moment, the single largest source of sea level rise in the world, partly because the Antarctic hasn't yet got going, and potentially the Antarctic can be a much bigger source, but it's not melting as fast. But I remember when I first started working in this area, and we went to the Met Office, the British Met Office, and they had a very lucid, supposedly, explanation of why the ice on Greenland was going to be lasting forever. The fact that you might get a little bit of melt in the summer, although you wouldn't get much because you're at a very high elevation. But the meltwater that will simply collect on the surface and then will refreeze again in the winter. So you've got exactly the same amount of ice in the winter as you had in the summer, and it will never melt. And of course, what they didn't realize is, of course, that a lot of the melt in the summer goes away. It flows away down into the base of the glaciers and directly into the sea. That didn't happen in their day, so they were very complacent. They said, in fact, one of the Met Office people, who is now a very distinguished member of the Met Office, calculated that the ice would last about 3,500 years, which is not that much, in fact. But it was enough for everybody to feel complacent. Sort of 3,500 years, we don't have to worry. But the survival time is coming down all the time because of the way in which the warming is increasing. the effects that nobody dreamed about, that is the levels of dirt on the ice sheet, which are making it darker and absorbing radiation more. Lots of new effects that are coming in, speeding up the melt. And you can't argue with the melting point of ice.
If the whole of Greenland's ice melted, how much would that affect sea level?
If the whole lot went, I think it will be about 7 meters.
Yeah, 7 meters. Yeah. But if we had 7 meter rise of sea level, probably about half of that would be from Greenland, and the other half would be from Antarctica. So, as you start getting meters of melt from Greenland, if some large region sort of calved off into the ocean and then broke up, that ice broke up, and then there was, a very abrupt rise in sea level. And we've seen this in the paleo records at various times. There's been sudden surges in sea level rise. And there's also scarring on the ocean floor off the coast of Greenland, indicating that large chunks of ice broke off and scarred the bottom before it broke up and melted. But then, the sea level rise would destabilize ice shelves and on Antarctica, right? There'd be a global sea level rise, and it would destabilize the ice, causing accelerated melting in Antarctica, and then that melting would then feed back to cause additional melting in Greenland, etc. So they're intricately connected, and I think in the periods of the Earth's history where sea levels being, say, 10 meters higher, then now about half of that has been from Greenland and half of it has been from Antarctica, with most of Antarctic part being from the West Antarctic ice shelf, which is ice that is sitting on bedrock that is well below sea level, even several kilometers below sea level.
What is this Thwaite ice shelf that they say is going to break off in 5 years?
It's an ice shelf in the Antarctic, which has a sort of peculiar thickness distribution. That is, it's not normally. It's not like it's thinner at the edge than it is in the land. There's a flow of warm water under it, which gives it a very odd and unstable shape. So the expectation is that, and because there's a lot of cracks in it, that may give way completely. Now, this has happened, and not long ago, the Larsen ice shelf in Antarctica completely fragmented, and it just went away, turned itself into thousands of icebergs. But in a sense, it didn't matter so much because the Larsen ice shelf was already afloat, and it didn't then have any impact elsewhere. Particularly, it only had the Antarctic Peninsula next to it. The trouble with Thwaites is that it's holding back some other ice movements, some other ice shelves and glaciers, which if the Thwaites fragments in the same way as the Larsen did, then it won't just be a local effect. There will be big impact on the flow of ice from other glaciers, and you really are going to get, they estimate, 0.5 meter of sea level rise, which is quite a lot to get instantly. That's we talk about when we talk about methane in the Arctic and the possibility of a methane outbreak, then we're talking about between 0.5 and 1.5 meters of sea level rise coming from that. So an instant event of 1.5 meters rise in sea level is a pretty catastrophic thing to happen, since the sea level rise happens all over the world.
It would happen instantaneously, practically all over the world, like within a day or so.
It would be a bit longer than that. But I mean, on a geological time scale, it's instant, even if it took 100 years. But, if a big chunk broke off into, it would take time to melt. It would take several years at least to melt. And, you could imagine sea levels spiking up, over a period of several years to 5 years to 10 years. And then you're at the much, much higher level sort of thing.
Mm-hmm.
So, I mean, time scale is always important, and also spatial scale, and people forget that. Like it's, there's a lot of noise out there in terms of climate data, like in any other thing. And this is why you need experts to sort of filter what is very important from what is not important. So this past week, there's been huge numbers of climate reports. You might wonder why. It's because the American Geophysical Union conference was going on in New Orleans. So there was, thousands of papers that were thousands of scientists, and probably thousands of papers and posters and stuff. It was combined in-person online conference. And so that's where the papers on, say, the Thwaites Glacier came out. There's papers on threats to the global food supply. There's papers on wildfire. So there's loads of climate topics that have come out.
The question is, all of the descriptions that you've given so far are predictions of what horrible things are going to happen inevitably. Now, have you, in any of these papers or in Glasgow, have you heard anything about new technological breakthroughs of any kind, any new ideas for resolving the problem or mitigating the problem?
Yeah, both he and I attended a number of different press conferences that looked at some potential things that we can do to try to mitigate the problem. And those include things like ocean pasture restoration, to use the oceans to capture huge amounts of carbon. Stephen Salter's marine cloud brightening, to actually brighten clouds over the ocean to reflect away sunlight to cause cooling of specific regions, whether you want to save a coral reef, whether you want to try to cool the water going up, the warm water going up and attacking the ice in the Arctic Ocean. There was also some sessions on using mirrors on the surface of the Earth to reflect away lots of sunlight, the Yi Tao type ideas. There was lots of things, but the bottom line is that the CO2 level keeps rising along with the other greenhouse gases almost exponentially in the atmosphere. And until that is stopped, until the curve is flattened and decreases, we're going to continue getting more and more extreme weather events, independent of how many COPs we have, et cetera. We can talk all we want. As long as those numbers going up, we're failing. And of course, why are those numbers going up like crazy? Because the world is paying $5.9 trillion to the fossil fuel industry every year. That amounts to about $11 million per what is it, $11 million per hour or something? I don't know. Like, the numbers are phenomenal. I mean, we're basically citizens of the planet are paying money via taxes to governments, and those governments are taking huge chunks of that money, paying it directly or indirectly to fossil fuel companies to mine and transport and produce more and more oil, and then natural gas, also coal, and we're burning it, and we're completely changed the chemistry of the atmosphere. This isn't rocket science. This is obvious, right? And unless those subsidies vanish and go into adaptation and mitigation methods, we're talking about huge pools of money, then our planet, we're getting in a worse and worse state with our planet. And we can't suddenly there's a lot of things we can't turn around. So if we continue to do this, then when sanity finally, if it ever does hit, world leaders and power brokers, et cetera, and the money, follow the money, then it is very possible that it will be, there'll be a lot of things that are irreparable. The carbon sinks on the planet are failing that have worked for centuries to remove carbon from the atmosphere and keep some sort of balance, and once we've destroyed those sinks by, say, warming oceans, losing the rainforests, then that carbon is going to be in the atmosphere and ocean at much, much higher levels. And then there will be a lot of people on this planet that just don't make it.
It sounds as if your number one priority, if you were trying to look at a policy change, the most urgent thing is to stop subsidizing fossil fuels. Is
Precisely.
that something that Peter would also agree is the top priority?
Well, I would differ somewhat here. In principle, I agree that it's greed that's the basis of it all, because when you look at COP meetings, for instance, we know the level of carbon dioxide in the atmosphere now because it's measured every day in Hawaii, and it's been measured since 1958, it's been going exponentially, rising exponentially, whatever we do. There's been endless meetings and conferences and agreements on restricting growth of fossil fuels, on trying to deal with fossil fuels. And the most important one, or the one that we say is most important, was the Paris Climate Agreement in 2015. But when you look at the graph of carbon dioxide level in the atmosphere, which is, of course, directly proportional to warming of the atmosphere, the two go together. Mm-hmm. The rise in carbon dioxide has been exponential, and it hasn't been affected at all by any agreement of any kind. The rise just smoothly goes up, and in an accelerating way. And when it goes up in that way, we really are doomed. I mean, we're not going to get anywhere if we can't even flatten off that curve, or we can't even stop it from rising more and more rapidly. And when you look at what is causing that rapid rise, it is subsidies and the sort of greed and laziness, because when we saw this year's COP meeting, the very last thing that was agreed, or not agreed, that is to say, that was inflicted on the UN, was China saying, "Oh, we're not going to start reducing our production of carbon dioxide until 2070. Until then, we're going to be building more and more coal mines and digging more and more coal." Now, 2070 is an insult to the entire human race, because we know that everything is so urgent that it needs to be addressed immediately. And we should be taking, and all the agreements that people have been making on the whole do at least talk about saying we must get observable change in the next 10, 20 years. The most that anybody says is 2050. But here along comes China happily saying, "Oh, 2070, that's our figure," which means by 2070 there won't be a world, and there won't be a civilized planet for people to live on, because the rise in carbon dioxide will have produced too much warming for us to go back to anything livable. And that sort of cynical greed on the part of a country which you would hope would be some kind of beacon, given that you're trying to keep a billion people fed, is just so cynical. And this also the same applies to India. and
Yeah.
there's no hope when the countries like India and China do nothing. Then there isn't any hope for the rest of us. I mean, we can have countries like Denmark or that are highly enlightened and reduce their emissions and develop ways of taking carbon dioxide out of the atmosphere. They're real kind of global citizens, but these are small developed countries, and they're outnumbered enormously by the huge undeveloped countries who couldn't care. And so we saw this awful thing at COP, and that was the thing that struck me most, was the fact that China didn't even turn up, but the fact that India was cynically saying, we're going to keep digging coal forever. Even our own government in Britain which was supposedly hosting all this, is going ahead and digging new coal mines and new oil fields. So
you have not said one optimistic thing this whole time. And
well, why are we supposed to? We're just telling you as it is. I mean,
I know, but
I mean, at one point,
I'm a kind of person who thinks, what can we do? Always I'm thinking in terms of what can we do? And honestly, I can't think of anything. The cloud brightening thing is the most hopeful thing I can think of.
Yeah.
And I don't know whether how realistic or how the logistics of how to make something like that happen, how much difference it would make and so on. But I think that we have to organize some kind of outcry, and the scientists sound like the meetings are just a litany of one catastrophe, a prediction.
Well, I mean, if you look at the trends, I mean, they talk a lot about 1.5 degrees and 2 degrees, right? And first of all, the baselines on when those numbers were first became a thing, they were based on the pre-industrial revolution, which is the year 1750, and now they're based on an average around the year 1900, which is already 0.2 degrees higher, at least, than the previous one. So putting that aside, we've already had months where we've been higher than 1.5. In fact, we had a month that was 1.8, right? Now, when we say that the globe is warmed, that would be the yearly average. And, it's quite clear, like we're going to exceed 1.5 at least, in the next decade, they're saying, okay, and 2 degrees in the decade after that. So
what can we do, Paul?
That's where we have it. Well, what can we do is, okay, well, what can we do is the question, right? I mean, what do we want to do?
One plan. Let's take the cloud brightening.
I talked about the one plan. Okay, let's take the U.S. military budget and put that money into trying to address climate change, adaptation to a completely renewable energy economy, taking all those subsidies out of fossil fuels. Many fossil fuel companies go bankrupt. We have some sort of energy issues. We probably build small modular nuclear reactors. We probably do some things which, because we have energy shortages from not burning fossil fuels, because renewables take time to ramp all the way up and cover for them. And we pull CO2 out of the atmosphere and oceans, and we cool the planet with solar radiation technologies. This is what we do to have a fighting chance at preserving anything that we have on the planet.
Peter?
But, I don't see any of that happening at the moment.
Yeah, no, I don't either.
I see a collapse of democracy in the US in a few years. That's what I see.
Right. I'm seeing that too. I mean,
I see global food shortages leading to famine.
Peter.
And read Kim Stanley Robinson's latest book. He understands climate. He's a science fiction writer. I think he wrote a book a few years ago, and it looks at like heat waves in India get much worse.
Don't predict
Air
anymore.
conditioning.
I've heard the predictions. It's awful. Peter,
Yeah.
tell me what to do quickly, and I will do whatever you tell me.
Well,
I
I've
want to
only
do
got.
something.
Well, I've got to leave in 5 minutes'
I know.
time, so I'll give you my optimistic view, which is there is an optimistic view, and it does consist of, first of all, it doesn't consist of relying on governments to do this. This COP has shown that the governments are complete dead lost. They are riddled with corruption, greed, and stupidity. I mean, the sheer level of stupidity I see all the time in Britain as a scientist, that the governmental people in Britain are unbelievably stupid people, and generally they've never studied science because they went to Eton, and so the people that are running science policy in the world are the people who shouldn't be allowed anywhere near science policy because they don't have any technical or scientific knowledge at all. But that means that it's left to us lot, the NGOs, the enthusiastic amateurs, or the enthusiastic people who are working with little funding on techniques for removing carbon dioxide from the atmosphere, air capture, and capture from the oceans. The guy I was talking about, who's growing kelp in mats, and if there's a breakthrough going to happen, it's going to come from work done by private and people and foundations. And suddenly, when the world is really right up the creek, somebody will cast around and say, help, help, we have to do something now. What can we do? And there will be things that we can do because that work has been done by the NGOs, by the foundations, not by governments. So then the governments will take it on, and so that's techniques for getting rid of carbon dioxide from the atmosphere, getting rid of methane. It will be done if it's done to the point where it saves us. It'll be done by us private enterprise scientists, or what, I don't know how you call people like us, but people who are not getting zillions of military funds and governmental funds, but still will come up with the science. I mean, you talked about marine cloud brightening, and I think that is one of the most promising things that I can see as far as cooling the Arctic is concerned. And yet the guy who's done that has not had any support at all out of the government. It's extraordinary. He's at the University of Edinburgh. He's developed a technique which works and has been modelled and tried, and it takes carbon dioxide. Well, it cools the atmosphere by reflecting more radiation. And you would think that at a COP meeting hosted by Britain, held in Scotland, he would be regarded as a sort of an international hero and lauded, and people would say, or the government would say, look, here's Stephen, he's a great scientist, this can save us, let's do this. But you don't. He's still staggering along with no support. So it's people like that who in the end will save us, if anybody does. Yeah. But we can't depend on governments to do it, because they are hopeless and stupid as well as greedy.
Yeah. And the voters keep picking them. So there's where the stupidity arises. Look, you go to your dentist. Hurry. Okay. I don't want to delay you 1 minute. I want you to get your teeth fixed. So run along. And okay. I'll say goodbye to Paul also in a more leisurely fashion. Bye. Go.
Okay, bye. Bye.
Great to see you, Peter.
Good to see you.
Thanks for this. Okay. So I'll say goodbye to you too, but we don't have to, you don't have a dental appointment.
No, I can stay for a couple extra minutes if you. So yeah, I mean, these techniques, there's lots of ideas for things that we can do. We need to find something that is scalable and that can be done fairly quickly to do those things like take CO2 and other greenhouse gases out of the atmosphere to try to restore the chemistry of the atmosphere to what we had, say, 50 or 100 years ago. And also to offset the heating or reduce or shield out some of the solar radiation, for example, and the solar radiation management techniques to cool the planet and give us time to completely eliminate fossil fuels.
This is where you need a social movement.
Yeah.
And I don't, here's the problem. It's just not coming together as a social movement. And I don't know why it's not adequate as a social movement. The scientists should be leading the way, but I don't think that's where the political leadership is coming from. So where does it have to come from? What can I, Meta Spencer, do to help develop a social movement demanding at least the interventions that you guys have mentioned as possibility? We need to think in terms of mobilizing public support soon.
Well, we did have 100,000 people in Glasgow in the climate marches, on one day, and many tens of thousands of people on other days. A wide cross section of people, lots of young people, and the urgency is there. It's getting there with the public, but it's obviously reaching brain dead politicians and world leaders who continue to just put the money into subsidizing fossil fuels. So it's as simple as that, really.
Well, I think we've done it. This is it, Paul. Well, we've finished as much of a conversation about this as we're going to be able to put together today, but we'll get back together again soon because this is not going away.
No, it's not going away. Okay, thank you.
Have a good holiday season.
Yeah, you too. Okay.
All right.
Goodbye.
Thank you. Bye.
Yeah, thanks. Bye.
Project Save the World produces one of these shows 3 days a week, sometimes more. And this is episode 389. You can watch them or listen to them as audio podcasts on our website, tosavetheworld.ca. Eventually, we even post the transcripts there. When you get to the website, do look around because we have conversations going on all the time about 6 global issues, plus potential reforms in governance, economics, and civil society. To find a particular talk show, enter its title or episode number in the search bar, or the name of one of the guest speakers. And after you've watched or listened, scroll down and share your thoughts about the show with the other viewers. This is the place for dialogue, so please do join in. See you there.